All right, so I looked in my YouTube notifications and I saw that there were some new comments on an almost 3-year-old video that I made, and it was also the first video that I made on the channel, and it was going over the snake method. And I rewatched the first ever video I made, and although I cringed a lot while watching it, I realized that uh, it was kind of vague. It only went over one example, so I thought, why not just make a better video going over the snake method if people still need help with it? So that's what I'm going to do today. So we're going to go over 3 examples here. I think they are maybe going to get a bit more difficult as we go. Depends on how you see difficult. Anyway, let's go to the first problem here. So we have x plus 2 times x minus 3 is less than or equal to 0. So we want to evaluate this inequality, uh, find the x values where this expression on the left side is less than or equal to 0. So in order to do this, we're going to do the snake method. So let's draw out our number line. Okay, and so this will go from negative infinity to positive infinity. All right, I'm just going to write infinity, not positive infinity, just infinity, but infinity is positive infinity. So now we just have to set each of our factors equal to 0. So we have x equals -2 and x equals 3. So we're going to put that on our line. And then since it is less than or equal to 0, we're actually going to include these, right? So this is going to, we're going to have one with a shaded in dot, right, at -2, and then a shaded in dot at 3. And I'm going to try to make this look as real as possible. So I'm going to put a 0 here just so that our number line is, somewhat accurate. But in our intervals here, we're not going to actually put 0. So just imagine 0 is here. Okay, so this here. Okay, so this is our number line. And so now what we really do is we just rewrite each of these factors. So it doesn't matter the order in which you write these factors, right? Because, these can commute, right? So we could put x plus 2 on the top, then x minus 3 on the bottom. We can flip around, put x minus 3 at the top, then x plus 2 at the bottom. Doesn't matter, and you'll see why. Okay, so now we just pick values in between these intervals. So from negative infinity to -2, we pick a value. From -2 to 3, we pick a value. And then from 3 to infinity, we pick a value. So let's pick a value, anything from negative infinity to -2. Okay, well, I'm going to pick -3. So now we take this value and we put it into each of our factors. So if we plug in -3 into x plus 2 here, we put -3 in for x. Doesn't matter what the actual number is, we just care about the sign. Okay, this is 2, by the way. So we plug in -3 in for x plus 2. We know that this is going to be -1, so that's just a negative value here. But negative, just a negative sign here. And then we're going to put in this -3 into this x minus 3 factor, -3 in for x. So we know that that's also going to be a negative value. Okay, now we just pick an x value in between the interval -2 and 3. So that's going to be, you can do just 0, right? Just try to pick easy values so you don't mess up on the arithmetic and somehow get a sign error. So now we plug in 0 into this x plus 2. We get a positive value. Put a 0 into this guy. We get a negative value. And then here, from 3 to infinity, I'm going to just pick 4. Again, you can even pick like 3.1 or something. Whatever works. It can be any value, just cannot be 3 itself, because then you'll get 0, and 0 is either positive or negative. So it just has to be in between this, not included, even though at the end we do include -2 and 3. So I'm picking 4, plug in 4 into the first factor. So 4 plus 2 is 6, positive. And then plug in 4 into this guy. 4 minus 3 is positive still. And so now I'm just going to draw a line below this. And so now we're literally just going to multiply each of these signs. Okay, so Starting multiplication signs here. So, and what this may seem confusing, but it really isn't. What is negative times a negative? Negative times a negative is a positive. What is a positive times a negative? Well, positive times a negative is a negative. Then what is a positive times a positive? A positive times a positive is a positive. So now we literally just draw our snake. Okay, so positive means we're up. Negative means we're down. Positive means we're up. Okay, so this is our snake. This is it. This is the snake, right? So now it's saying where is it less than or equal to 0. So when we look at less than here, when we look at less than, we're looking for the negative. So that's going to be between -2 and 3. So interval notation, we write it as x is an element of, or x belongs to the interval, and then because it's less than or equal to 0, we have to put brackets, and so this will be -2 to 3. And if you want to write this in inequality notation, that's going to be x is greater than or equal to -2, less than or equal to 3. Okay, so that's our answer to this problem. So again, really straightforward. Okay, it's just following a process, following a procedure. You can always feel free to test this out by plugging in values. Like you can plug in -2 into this, you'll see that it'll be 0. Plug 3 into this, it'll be 0. That's fine because 0 is greater than or equal to 0. Plug in values in between this interval, you'll see that it'll be less than 0. Like a negative number is less than or equal to 0. Let's see, it's true. Okay, so you can always check if you're unsure. But this process, it got us the interval. So just make sure, again, pick values in between each of these subintervals and then go from there. Okay, this one, very similar to the last one. Got an additional factor here. Process doesn't change. Remember, this is, again, greater than 0, so we just look for the positive guys on our snake here. And then also, this is not greater than or equal to 0, so we just don't include our x values. So let's do this again here. And feel free, if you've got it already, you can do this example on yourself. The next one, though, I kind of pay attention to. It's a little bit different. There's a caveat. But yeah, I mean, you can go through this together so if you want. So set each factor equal to 0. Okay, so we have 8, -1, and 5. Okay, so right, -1 here. Okay, and remember, we don't shade in the circles because they're not included. Okay, because we don't have a greater than or equal to. We just have a greater than. Okay, so we have -1 here, and then we have a 5 here, and then we have an 8. Okay, and again, if you're confused, again, I'm literally just setting these equal to 0, right? So I'm doing x minus 8 equals 0. X equals 8. That's all I'm doing. X plus 1 equals 0. X equals -1. X minus 5 equals 0. X equals 5. That's all I'm doing here. Okay, so that's how I put this here, I put this here, and I put this here. So that's all I'm doing. So now just list out our factors, right? Into a row of our factors. Doesn't matter the order because again you're just multiplying, so you can change the order of multiplication and commute, right? So that's allowed that is allowed. Okay, it's about property and multiplication. So we write our factors. So we have. I'm just going to do it in order, whatever. You can even switch. You can obviously switch it. Like I can put x plus 1 here. I can start with that. Do x minus 8. Do x minus 5, or I can just switch it to any way I want. So I'm just going to do it in order. X minus 8, x plus 1, x minus 5. Okay, x minus 8, x plus 1, x minus 5. So now, again, same process here. I'm going to actually write our signs here, negative infinity, infinity, just to know that, okay, all real numbers, we're on the real number line. So now, just pick values in between these subintervals. So from negative infinity to -1, let's do -2. Plug it into each of these factors. This is going to be negative. This is going to be negative, sorry. This is also going to be negative. So all of these are negative. Okay, so let's double check here. -2 minus 8, Again, I would recommend double checking here if you have more than two factors, just to be sure, because one tiny slip up in signs can really change your final sign. Okay, so negative 2 minus 8, negative, negative 2 plus 1, negative, negative 2 minus 5, negative. Okay, so now here I'm going to just do 0. 0 is very convenient. So now this would be negative, positive, negative, right? Oops. Negative, positive, negative, right? So 0 minus 8, negative 8. So negative 0 plus 1, 1, positive, 0 minus 5, negative 5, negative. Okay, so now from 5 to 8, I'm just going to do 6. Okay, so 6 minus 8, negative. Uh, 6 plus 1, positive. 6 minus 5, positive. Okay, a common mistake is people miss one of the intervals because they're so small, like from 5 to 8. That's not a very large interval, but make sure it is still a subinterval. So make sure to test for that interval as well. So again, let's check 6 minus 8, negative 2, negative 6 plus 1, positive 7, positive 6 minus 5, positive 1, positive. Okay, now from 8 to infinity, I'm just going to pick 9. Why not? 9 minus 8, positive. 9 plus 1, positive. 9 minus 5, positive, right? Okay, let's check. 9 minus 8, 1, positive. 9 plus 1, 10, positive. 9 minus 5, 4, positive. Okay, so now, again, we draw our line. Okay, so now we just put our multiplication sign. So we multiply each sign. Okay, make sure you pay attention to what you can, again, like I did, do your double checking, just check if your signs are right, because again, you could have a negative times a negative to positive, but then one negative can change it back to negative. So make sure this is correct, okay? Again, like I double check myself because I could have made a simple mistake. So anyway, so let's actually do some multiplication here. So negative times a negative is a positive, times a negative is a negative. At that negative sign. And then negative times a positive, negative times a negative is a positive. Again, if you're confused, you can just rearrange it to negative times positive. So then negative times negative is a positive. Times positive is positive. Here we get negative times positive, which is negative, times positive, which is still negative. And then positive times positive, which is positive, times positive, which is just positive. So now let's draw our beautiful snake here. Okay, so this will be negative. This will be positive. This will be negative. Positive. This will be negative. And then this will be positive. Beautiful snake right here. Very nice snake. So now, what is it asking? It's asking where is it? Where is this? Alright, I apologize. It seems like my computer crashed when I was trying to use the highlight tool, but it seems like we're back up. So anyway, as I was trying to highlight here, hopefully it doesn't crash now. So we've drawn our snake. So now, again, we need to pay attention to this is greater than 0. So we're looking at the positives. So it's a plus and a plus. We see that right here. So where are these pluses in between? Well, they're in between negative 5 or negative 1 and 5, and then 8 to infinity. So again, also paying attention to the fact that this is not greater than or I'm trying to switch here, greater than or equal to. It's not, it's greater than, and that we have open circles. So we're going to use parentheses instead of brackets this time. So in interval notation, it'll be x is an element of or belongs to negative 1 to 5. And then here we're going to use union, right? Union's like our or. So it's saying then from 8 to infinity. Okay, so this is how we do an interval notation. If you want to do an inequality notation, it would just be x is greater than negative 1 and less than 5. Or you can also put a union here. That's fine as well. X is greater than 8 and less than infinity. These are both correct. And again, you can check by plugging in values in between these intervals into this guy right here to see if it is greater than 0. Okay, so yeah, let's move on to the next one here, our final example. This is the one where there's a bit of a caveat here. So in order to make this a bit more spicy here, you probably notice that the numerator and denominator are not factored for you, or you're not given a factored form at all, like you are in these two examples. So that means we're just going to factor it ourselves. Okay, so hopefully you realize here that this is a squared minus b squared, where a is x and b is 2. So we're going to just rewrite this as x plus 2 times x minus 2 over then this x squared plus 6x plus 9. Hopefully you realize that this is just x plus 3 the whole squared. Okay, to make it maybe a little bit better for us in this kind of problem, we can rewrite it as x plus 3 times x plus 3. I'm going to talk about how we deal with this, and then going to be less than or equal to 0. So now, again, just our general process here, draw the number line, okay, put our negative infinity here, our positive infinity here, and then set each thing equal to 0, okay? So we have x plus 2 equals 0, so x is negative 2 here, and then x is 2 here. X is negative 2 here, and then x is 2 here. And then denominator, okay, we're going to set these equal to 0, but then we're going to talk about how we deal with this. So again, I'm going to plot our negative 2 and 2 accordingly here. So this is, okay, remember this is less than or equal to 0, so we're going to shade in our circles here. So this is going to be negative 2, and then this is going to be positive 2. Okay, so now denominator, we also set these equal to 0. So we have x equal to negative 3 and x equals negative 3. Okay, so these are reoccurring. Okay, so that's fine. Okay, that just means in our list here, when we list the factors, like in like the rows of factors, we're just going to put x plus 3 twice. Okay, but another thing to pay attention to is that these factors are in the denominator. So what we need to pay attention to is in the denominator cannot be 0. And so in this case, the denominator is 0 if x equals negative 3, because if we plug in negative 3 into this guy here on the left, we're going to get something over 0. Okay, and we don't want that. Okay, that means this is not defined. So we are going to put our negative 3 here, but just because we don't want negative 3 at all, I'm just going to put, again, you can put an open circle. I'm just going to put a line here. I'm just going to put negative 3 here, okay, just to show that the function is not defined, or this expression here on the left is not defined at x equals negative 3. So I'm just going to put, a line there, kind of a vertical dash here to show that it's just not defined here, and so then we can take that into account when we're writing our intervals. So now the process is literally exactly the same. So write our factors, doesn't really matter the order, doesn't matter the order in which you write them. So it's just x plus 2, x minus 2. Again, I'm just going like from left to right, a numerator denominator, but you don't have to do that at all. You can mix and match whatever you want because we can commute. So x plus 2, x minus 2, x plus 3, and we're going to just write x plus 3 twice, okay? So, right, we have x plus 3 and x plus 3. So, again, we're just writing down each factor, okay? Because while we still have x equals negative 3 twice, kind of like multiplicity 2 kind of thing, we're still going to write x plus 3 twice. So now, again, just pick numbers in between the intervals. So from negative infinity to negative 3, I'm just going to pick negative 4, okay? Plug it into each of these factors here, okay? And be sure that you don't skip an interval, okay? Make sure you don't skip an interval. So negative 4, plug that into each of the factors. This should be negative, this should be negative, this should be negative, this should be negative. Okay, just check here. Negative 4 plus 2, negative, negative 4 minus 2, negative, negative 4 plus 3, negative, negative 4 plus 3, negative. Okay, so from negative 3 to negative 2, okay, this is where our values are a bit more strict here. I'm just going to do like negative 3.5, okay? Okay, because that's, again, real number in between -3 and -2, so it works. So -3.5 plus 2, hopefully you know that that's just going to be negative. -3.5 minus 2, also going to be negative. -3.5 plus 3, negative. -3.5 plus 3, negative. Okay, and so now from -2 to 2, I'm going to pick 0. So then positive, negative, positive, positive. Okay, and then from 2 to infinity, I'm going to pick 3, positive, 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 positive. Okay, right? Just want to check here. 3, so 3 plus 2 is 5, positive 3 minus 2 is 1, positive 3 plus 3 is 6, positive 3 plus 3 is 6, positive. Okay, so now we draw this line below. Okay, and then now we just multiply each of our signs. Okay, just draw the multiplication signs. Okay, so now let's do this in order here. So negative times a negative is a positive, times a negative is a negative, times a negative is a positive. So this is going to be positive. Negative times a negative is a positive, times a negative is a negative, times a negative is a positive. Positive times a negative is a negative, times a positive is a negative, times a positive is a negative. Positive times a positive is a positive, times a positive is a positive, times a positive is a positive. Okay, so now let's draw our beautiful snake. Okay, so now we're gonna have and okay, so one thing to note here again, your answer is not the snake, but I still think it is kind of important to draw the snake correctly still. So now, since you think, oh, we have two adjacent positives, we can just skip over this -3 and just go straight to the -2. Yeah, but no. Okay, what you have to do is, okay, this is, again, this is where the snake is not really a snake. It doesn't really look like a snake here. We're going to go to the -3 here, and then we're going to go to the -2. That's how we do it. Okay, so there's still plus, but again, we just have to take into account that -3, and that's where the function is not defined. Even if, again, you have two adjacent positives and you don't have this denominator case, you still should be doing this. Like if you have specific, numbers on your number line, you have to include all of those numbers in your interval. You can't skip any of the numbers. Okay, so then here we got negative, so we're going to have a big negative here. And then here we have a positive. Okay, and so remember, this question is asking us less than or equal to 0. Okay, again, less than or equal to is good, right? We have the closed, shaded in circles. So now what we're going to do here is we're going to actually now just look. This is negative, right? So now we just do an interval notation. That's going to be x is an element of, or x belongs to the interval -2 to 2. And then, of course, we want to do an inequality notation. That's just going to be x is greater than or equal to -2 and less than or equal to 2. Again, plug in values, and you'll see that this should work. Okay, so that's our answer for this. Okay, so if I think that if you understand this video completely, I think you should be fine with snake method and all the problems thrown at you involving snake method. If I didn't cover a certain kind of example or you're kind of confused in general, just let me know in the comments and I can try my best to answer. All right, yeah, blast from the past. This is my first ever video topic, and now I'm doing it again. All right.